what really drives us now to get into the automatic machine translation, or we call it as AMT. It's a very ideal thinking, right. So, if, I speak one language, and then a person in Africa who only understands Swahili understand what I am speaking. For example, he does not know my mother tongue and I do not know his mother tongue, but I speak in my mother tongue. And then when I pick up the phone and then call him, for example, he is one of the best teachers for certain subject, and I want to hear from him about certain ideas that I have generated. So, I call him in my mother tongue, and then he understands what I am saying in his own language, because there is some, let us assume that there is some black box that converts that, and he speaks in his own mother tongue Swahili, and then when I receive the translated version in Tamil. So, I am able to really converse with that person in real time. So, it is a very ideal thinking. That means, you are breaking the complete boundary of language in the world if you are able to do this. So, this is the ideal situation, and this is what we want to get to. I am not sure how long it is going to take us to get there, but that is where people are working on, and research is really getting into that direction. Right. So, the most important aspect of any translation is to have an error free translation. So, when I translate, I just want to really create an error free translation without any semantic and syntactic errors associated with that. That means, we are preserving the meaning of the source language without adding any noise to that. So, now you know that it is not a very easy problem, it is a very hard problem to solve. Okay. So, how do you solve, where do we start? That is where a lot of parallel corpora that are available would help us. Okay. So, that is a plural. Okay. So, if you look at the European Parliament, they have translations from one language to the other, whatever has happened in the parliament been coded. For example, it is available from English to French, French to German, German to Spanish, and then Spanish to whatever other languages that they speak there. Okay. So, this is something that we really need. So, what does this contain? Let me take you to that first. Okay. A parallel corpora is a collection of corpus that contains a collection of original text and its translation in various languages. Okay. Suppose if the language of communication in the European Parliament is English, then they have the translated version of that in all languages. It is translated by human. They have not used any automatic translation, probably they would have used as the initial stage, but at the end all are corrected and verified in the manual fashion. So, we assume that this particular corpora will give us the exact translation of one sentence to the other or from the source language to the target language. So, what does it contain? If you go and then look at their corpus, it is all listed in pairs though. Okay. You can take English to French or French to English or French to German, and then when you look at that file, you will have two sets of text file, one containing English, other one containing French in this case. Okay. And then the first sentence of the English text would correspond to the first sentence of the French. So, they are two different files. So, you have to really map them to create your own parallel corpora if you want to run it through your applications. So, they are two separate files, the European Parliament data. Okay. Let us go back. All right. So, let me show you what can be done, right. So, so far we have not looked at the language from the syntax perspective. We have been only looking at it from the data perspective, and we want to continue to do the same. We do not want to get into the aspect of the grammar and things like that. So, we want to see whether the word embedding can be created using the data that is found. We want to find out whether languages, whether a sentence can be translated from one language to the other using the data that is available in the parallel corpora and so on. Okay, so, how do we really start? It is very interesting, thanks to the efforts of the researchers that we have right now. We are able to have application that translates from one language to the other. For example, I used Google Translation for this, okay, and we will learn how to really translate from English to the other language which we really do not know. Okay. I have taken English as the source, okay, and then the target is Swahili. I do not know how to pronounce these words. I do not know this language, but I just want to see by looking at the words, is it possible for me to understand what each word means in that language. Okay. So, let us first look at one sentence. This is my house. So, pardon my the ignorance in this language. So, I may be wrong in terms of pronouncing this. This is Hai Ni Nyumba Yangu is the translation. Okay. So, from the first sentence we do not understand what corresponds to what, right. So, there is no one to one, there is some one to one correspondence, but we do not know whether the correspondence is correct. My dog loves to run. Boa wangu anapenda kukimbia. Okay. So, there is only one my here. Okay. There are two words that are equal. So, we still do not find, but there are certain things that sound similar. So, we can assume that my could be corresponding to either this Yangu or Wangu. Okay. I run with my dog. Mimi kukimbia na boa wangu. So, now there is third my around here. So, there is a Wangu here. So, we can say for sure with certain probability that my could correspond to Wangu, right. So, now we have the second word dog, we have this Mbwa, there is one more here. So, dog may correspond to this, right. So, you look at the third sentence, my house is blue in color. Okay. So, there is a translation available, and then this blue, by looking at this we can say that this could be okay. So, now we know my, and then here we found house in the first sentence, and then in the last sentence we also has this. So, this could be our house, right. So, it is possible for us, right. So, if you have the languages side by side, and then we probably would be able to do the translation by analogy. It could be we probably would be able to translate word by word, but we may not be able to formulate a sentence based on this. Maybe if we have seen thousands of such translation, we might be able to do the translation from English to Swahili too, right. So, this is the idea, right. So, now we are able to really count how many times certain words are associated from the source to the target. So, once you are able to really find out that this particular word has been associated with this several times, okay, then we can for sure saying that the word in the source language is associated with this word in the target with certain probability. Okay, this is the idea. So, this is how we are going to be looking at the corpora and then trying to find out the translation aspect of it, and then try to formulate various algorithms to do this job. All right. Actually, I just wanted to ask you this question. This is my dog. Okay, so how do you translate this? Okay, so we have seen that there is some HII, and then is maybe NI, and then my we saw either it is Yangu or Wangu. Okay, so since it is associated with the dog here, my there is a Wangu there, so maybe I can and then MB WA, it could be here or there. Okay, so if you use the Google translation, it tells me that this is it. So, somewhat we are able to really translate from the source language to the Swahili depending on what data that we had seen earlier. Okay. So, this is what we call as statistical machine learning. So, we are able to really count how many times certain words are occurred, and then how many times those words had from source to the target had been aligned, and then create a count of the probability of that particular word. For example, if my is associated with the Yangu, so we will have the probability estimation like or let us say this is the count, let me put it straight. How many other times we had seen my. So, this will give you the probability of the translation for my given translation Yangu given my. Okay, so, we can write it in this fashion. Okay. This is the model that we are going to be following in this session for machine translation. Okay. So, for us to train, we need to find the model parameters and then later apply to the unseen data like what we had done here, right. Okay. So, this is the definition that I will be using. Statistical machine translation is defined as follows. Translations are generated using parameters in model which are derived from the analysis of bilingual text corpora. So, by looking at the parallel corpora, we are going to be generating the parameters, and then using the parameters we will develop a model, and then using the model later when we input a sentence that is not been seen earlier, it would give us a translated version, and then we can use some kind of a gold standard to find out whether the translated version is really a legal sentence or not a legal sentence. All right. Okay. Okay. So, that's another thing that I want to talk about here. For a given sentence, there could be various ways of saying the same in a target language. For example, it is a very archaic way of saying in French, comment allez-vous. You can, in English, you can translate that into how are you, how do you do, how are you doing. So, same way you can comment ça va or vous allez bien, ça va. I do not know whether that is the right pronunciation. Okay. So, all it can be translated into multiple sentences that mean the same. So, it is possible for you to translate a source language into multiple sentences into the target language as well. So, what we want to find out is we want to find out which one is the which one is likely to be translated in the right way by looking at the probability of each one of those sentences, and then whichever one has the highest probability, then that we will choose as the translated sentence for the source that we had provided. All right. So, let us assume certain things before we move forward. So, the task here is to translate a French sentence which contains a sequence of words. Okay. Remember the sequence, right. So, it really takes you into the neural net way where we have utilized a recurrent neural network for operating on sequence of strings, right. So, we are going to be having a sequence of strings that will describe a French sentence F, okay. And then F j is the jth sentence, whereas j equal to it can vary from 1 to m, and m is the number of words in the French sentence. Okay. The same translated version could have the same number of words, m words, or more or less, right. So, let us not use the same notation for English. The translated English sentence will be assumed to have a sequence E1 to En, where m is not equal to n in many cases, and n is the length of the English sentence or the number of words in the English sentence. Okay. So, when you look at the corpora, there is not going to be just one sentence, they are going to have many of them, right. So, we have to define that as well. So, let us look at the parallel corpora that contains consists of the pair of source and translated sentences in this fashion, F k and E k. We know that F represents the French sentence, E represents the English sentence, and k here refers to the kth sentence in that corpora. So, there could be about 10,000 or 20,000 versions or pairs of source and translated versions. K represent the kth sentence of both English and French. Okay. The parallel corpora are available from the Canadian parliamentary proceedings. You can also get it from there, or you can get it from the Europol data. Okay. So, Europol is preferable because it contains lots of other languages too, not just French and English. Okay. So, we spoke about this earlier, and then we also need to understand a few technique that we would be using here. So, one is called the argmax. Okay. So, as I mentioned earlier, there is going to be more than one sentence in the translated version for a source language, right. So, which one should I pick up? So, that is what this is going to be telling us. So, if you have multiple sentences and then you find out what is the highest value or the probability, and then pick that word. So, in this case we have the highest happening here, okay, and then the 0 index is your sentence that you want to pick up. Okay. So, if we have so many sentences arranged in this fashion, and then you pick up that index where the maximum occurs. Given a French sentence F, find the most likely English sentence that maximizes the probability of E given F. Okay. So, the arguments, this will give me the sentence here, right. So, since as I mentioned, there is possibility of having more than one translation, argmax will capture one English sentence that yields the highest value for the probability. Okay. So this is the conditional probability, and then the highest value for this conditional probability will be taken as the translated sentence.